Hey guys, I don't know what just happened. So hey guys, welcome to the new video. Today is 27th of November and we are doing another challenge which is called partition equal subset sum. What is this? This is a cheap trick to not edit your videos. I just opened this and I won't be editing my video from now on. I'll just be recording this video. So what is this partition equal sum subset sum? See, imagine if you have an array and if you can break that array into two equal subsets, and the sum, but the only condition is that the sum of both the subsets must be equal to one another. If we take this example, here it is clearly stated that 5 can be broken down into two subarrays, which is 1, 5, 5 and 11. Quite simple. If we do a few more examples, we can draw some conclusions, which I did. And the first conclusion is the total sum of the array must be even. So if it is not even, it is clear that no other halves can complete and become the sum of this array. Let me explain. If let's say my sum is 19, if I can't split my array into two halves of equal sum, let's say having a sum 9.5 and a 9.5 there. So if my sum is not even, it is not possible to divide the array into two subarrays with equal sum. Again, another conclusion that I had drawn, let's take this example only. So if I find a number, in this case it is 11, to be equal to half of the total sum, then it is clear that rest of the number, let's say this array would be 11. If it was 11, then rest of the numbers, in this case 1, 5, 5, or in the other example 11. So rest of the number will combine and make the other half of the total sum. So it is clear that if I found such a number which is exactly equal to the half of the total sum, then I for sure know that I can divide it into two equal halves, two partitions, not equal partitions with same sum. In one side would contain just that number and other side will contain all the rest of the numbers in that array. Again, if I found a number to be more than that, when would that happen? Let's say I have an array 13, 7 and the total is 20. So it is obviously even, so it won't give false here, and here it will return false because 13 is greater than 10. So if I have a number in an array which is greater than the totals, which is greater than half of the total sum of the array, I can't divide it into two separate halves because we only have positive integers, we don't have negative integers. This all is clear. Then we move on to a recursive function. Firstly, ignore this hash map right now because this is something that I had to do to optimize the solution. And before that, what I did is I simply did again. If I calculated the sum of that sub array. Here I have a subarray, which in this function, let me explain what this function has. This function firstly needs a sum array. Second, it needs an index. Again, it needs a sum of that elements. If the index is 1, then the only one element, the sum is 0 right now. The total sum, which we are not calculating over and over again, and next hash map, which I'll let you know why I used it here. Then in this, first what I did is I checked if the sum is equal to half of the total sum. The sum right now is 0 as we stated here, so it will obviously return false for now. Then what we do is this is the base condition to return true, and this is the base condition to return false. So we must have a base condition to return false also. Otherwise, this how many times will this recurring function call itself? So the base condition to return false is if the sum is more than half of the subarray, the half of the sum of that array, the sum of the subarray is more than half of the sum of the actual array, or the index has exceeded the nums dot length, then we return false. Otherwise what we do, we return, let's not do this, let's just focus on we creating this, and we are returning this. So we return the or of, first we again call this function and we include the first element, then we do not include the first element, I'm so sorry. First we call the function and we do not include. For now the sum was 0, it still remains 0, and we again call this function and we include this element, we increase the sum and we add this element to that sum, and we take or of this and then we store it in a variable, and then we return the variable. If you would do the tracing of this in a recursive, if you know how to trace a recursive call, and if you would do it on a pen and a paper, or if you could see why we did it, it is really simple. This solution, this is quite a famous problem. This problem is asked by Facebook, and this solution was not that difficult, but optimizing it was. So I submitted the solution before this and it gave me a TLE, a time limit exceeded. Why? Because this is taking a huge amount of time. If I'm calling this function again and again and again, because I'm calling for index, I'm calling this function twice, with some included and with some not included, and with that number included in the sum. So what I did is I created a map, I created a unique identifier string which will be index plus sum, because I need to identify, I need here the index is same for both the calls, if you will notice, but the sum has changed. So and it might just happen that the sum for another call be same, so I need two variables in that string to make it unique. Hence I used a string as well as the sum variable, the combination, the amalgamation of two. Then what I did is, it's just a new word I learned yesterday. I knew this word, but I'm trying to use these kind of words in my daily life. Okay, so what next what I did is I checked if my hash map already contains it or not. If it does, return. If it's return true, false, whatever it has. Else, if it does not contain that, do all this, and instead of returning this just add this to the map and then return this, return the variable if it's true or false, and your solution will be accepted. The time complexity is a bit tough to analyze, but yeah, it's okay, and it is not that okay, but the question is pretty simple. Thank you guys.